Hello students, good morning. You are welcome in the lecture number 15 of a chapter of chemical thermodynamics. In the lecture number 14, we have seen Hess law of constant heat summation. That law is stated as overall enthalpy change of a chemical reaction is equal to the summation of enthalpy changes in individual steps of the chemical reaction, and that Hess law of constant heat summation is the direct consequence of enthalpy as a state function. Enthalpy change as a state function. There we have seen the example of formation of carbon dioxide by two different ways, and by all those two different ways the enthalpy change is constant. Enthalpy change is constant. Whether the formation of CO2 is taking place in one step or it is taking place in two steps, every time change in enthalpy is constant. Therefore, Hess law of constant heat summation can also be stated as enthalpy change in a chemical reaction is always constant, independent of path followed by the change, or irrespective of number of steps involved in the chemical reaction, and depends only on initial state and final state. That is the Hess law of constant heat summation. There we have seen the applications also. In applications we have studied Hess law is applicable to calculate the enthalpy change of the reactions which are not directly taking place. We can calculate the enthalpy change of very fast reaction. We can calculate enthalpy change of very slow reaction, and numerical example based on Hess law of constant heat summation we have studied in the last lecture number 14. Now in this lecture we have to study spontaneity, spontaneous processes. So let us see over here what is meant by spontaneous process, or that is also known as irreversible process. Spontaneous process or irreversible process. There are many processes occurring in nature. Naturally, many processes are taking place in the nature, in the surrounding atmosphere. Those naturally occurring processes which will not require the influence of external energy. The processes which are taking place naturally and which will not require the help or influence of external energy are known as spontaneous processes. These processes are taking place in only one direction. These are the processes which are taking place in only one direction. So let us see certain examples. Suppose, let us consider the example of rolling of ball. Suppose we have this type of ground. If the ball is placed over here, what happens? It rolls down. It comes down and gets settled at this position. Here the energy of ball is higher. Potential energy of the ball is higher. And it comes to this level where the potential energy of ball decreases. It maintains the equilibrium position. This is the downhill rolling of ball. So downhill rolling of ball from higher level to lower level take place on its own accord. Rolling of ball from higher level to lower level take place on its own accord without taking the help of external energy, external agency, and that is known as a spontaneous process. It is taking place in only one direction. Once the ball comes over here, it will be stable. Further rolling is not possible because the ball has maintained the equilibrium position. Let us consider another example. Flow of water. Flow of water. We know always the flow of water takes place from higher level to lower level. Water flow takes place on its own accord without taking the help of external energy from higher level to lower level. And at lower level what happens? Here it becomes settled. In a dam the water becomes stable because it maintains the position of equilibrium. Here water has higher content of energy. It falls from higher level to lower level, therefore its energy decreases and it becomes stable. Let us consider the third example, one more example. If we add NaOH and HCl together, this reaction is known as neutralization reaction. The reaction in which acid react with base to form a salt and water, NaCl, salt and water. This reaction is known as neutralization reaction, and this reaction is exothermic in nature. Exothermic in nature. Immediately as soon as NaOH and HCl are added together, they undergo a chemical reaction and they form NaCl and water. This reaction is taking place in only one direction. Only one direction. They combine together forming these products. But if we add NaCl to water, formation of NaOH and HCl is not possible. Therefore, this reaction is taking place in only one direction. And this is taking place with evolution of heat. We have studied endothermic and exothermic chemical reactions. Endothermic reactions are those reactions which are taking place with absorption of heat, and exothermic reactions are those reactions which are taking place with evolution of heat. This reaction is exothermic in nature, means NaOH react with HCl to form NaCl and water with evolution of heat. Enthalpy change is negative and this is exothermic reaction. These products are with less energy and reactants will have higher energy. Let us consider one more example. Hot tea. Whenever taken in a cup, what happens? It releases the energy and become cool. Cooling takes place. Hot tea, whenever taken in a cup, loses energy, releases heat and become cool. There also release of energy takes place. Hot tea has higher energy and cold tea, after cooling, cold tea has less content of the energy. These are certain examples of spontaneous processes or irreversible processes. See, this process is taking place in only one direction, higher level to lower level. This also taking place in only one direction, higher level to lower level, naturally. Higher energy content to lower energy content, and higher energy content to lower energy content. All these processes are taking place naturally. These are the processes which are taking place naturally without absorbing any energy. They will not require any energy. In the nature itself they are taking place. And these are, since taking place in only one direction, they are known as irreversible processes, or these are the spontaneous processes. So spontaneous processes are nothing but naturally occurring processes which will take place on their own accord without taking the help of external energy, without taking the help of external agency, are nothing but the spontaneous processes. Now see what happened during the spontaneous process. In this process, which is taking place in only one direction, energy decreases and ball maintains the equilibrium position. Here also energy of water decreases and water maintains the equilibrium position. Here also energy of NaOH and HCl decreases, or in the last case also energy of hot tea decreases after cooling. Here energy decreases. NaOH plus HCl react together. They are having higher content of energy. Converted to product NaCl and water, they are having less content of energy. This is exothermic reaction. Therefore energy decreases during the reaction. Here also hot tea become cold, energy decreases. So all these processes are taking place with decrease of energy. These are the processes taking place with decrease of energy, and they are maintaining the state of equilibrium. Therefore, spontaneous processes are the processes which have a tendency to lead to the state of equilibrium. The processes which have tendency to form, to acquire the state of equilibrium are known as spontaneous processes. So, all these processes are taking place with release of heat. Now, let us consider A is the initial state, B is a final state. When this is spontaneous, just now we have studied, if this will have 100 kilojoule of energy and if this is having 110 kilojoule of energy, is it spontaneous or non-spontaneous? According to this concept, according to these examples, this is non-spontaneous, because we know that the energy of final state is less. Energy of final state is less as compared with the energy of initial state. So this must be less than 100. It should be less than 100. Let us consider 90. So what is delta H? Change enthalpy. It is enthalpy of final state minus enthalpy of initial state. So 90 minus 100. So it is equal to minus 10 kilojoule. Minus 10 kilojoule. And for all these reactions, the enthalpy change is negative. Therefore, it is considered that the processes are spontaneous whenever enthalpy change is negative and the reaction is exothermic in nature. So, what is the criteria over here? With the help of enthalpy change, what we can say? We can say that if the enthalpy change is negative, the process is spontaneous. It means opposite manner. If enthalpy change is positive, the reaction is non-spontaneous. And if the enthalpy change is 0, the process is at equilibrium. These are the three important conditions. The first condition studied over here is nothing but on the basis of enthalpy change. What we have studied, we have seen that if delta H is negative, means delta H is less than 0. Negative means less than 0. This process is spontaneous and irreversible. Secondly, if delta H is positive, means delta H is greater than 0. This process is non-spontaneous. Non-spontaneous means reversible. This is irreversible and this will be reversible. And third case, whenever delta H is equal to 0, this is the process at equilibrium. The process is stopped because it has maintained the state of equilibrium. So this is there on the basis of enthalpy change for a spontaneous process. But if we consider now certain examples, let us see one example over here in which this is not applicable. It is not applicable. Suppose consider the example of water in solid state, that is ice, converted to water in a liquid state. Solid water, ice, whenever kept open to the atmosphere, what happen? It is converted to liquid. Ice, piece of ice, whenever placed open to the atmosphere, what happen? It absorbs heat from atmosphere and converted into liquid state. Here is absorption of heat. Absorption of heat take place, means is this endothermic or exothermic change? Endothermic. And for this, what is the value of delta H? Delta H, is it positive or negative? This is positive. And as delta H is positive, means this process should be non-spontaneous. But it is spontaneous. This is also naturally occurring process. So why it is naturally occurring process, even though it is endothermic in nature, is not explained over here. Therefore, the criteria of exothermic nature or endothermic nature is not sufficient. Criteria of exothermicity is not sufficient in order to explain the spontaneity of a process. So, certain another concept is required, and that another concept is known as entropy and entropy change, delta S. It has a designation of symbol delta S, entropy change. Entropy is defined as a measure of randomness, measure of disorder present in the system. Measure of randomness or measure of disorder present in the system. So for example, let us consider this case, H2O solid. Solid is nothing but ice, where molecules are close to each other. Whenever converted to H2O liquid, where molecules go quite away from each other. As molecules are away from each other, what happens? Randomness increases, disorder increases. Or if H2O liquid is converted to H2O gas, again gas molecules are far away from each other. They are very far away from each other. Randomness increases. So it is considered that the processes in which entropy change increases, entropy minimum, solid state, because randomness minimum, order is maximum, disorder is minimum. Here in gaseous state, entropy is maximum because randomness is maximum, disorder is maximum, order is minimum. And in this case it is the intermediate state, therefore intermediate entropy. So what happens whenever randomness increases, means disorder increases, entropy also increases, and it is considered that the processes in which entropy goes on increasing, they are spontaneous processes. Consider the case of iodine gas. Iodine gas. By sublimation, what happens? It is converted to iodine solid. Entropy of initial state S1, entropy of final state S2. What is delta S? Delta S will be S2 minus S1. Iodine gas to solid. In which case randomness is maximum, solid or gas? Gas. For gaseous state, randomness is maximum, disorder is maximum, and for solid, disorder is minimum. So if this is 100, this will be less than 100, so let it is 10. So this will be 10 minus 100 minus 90, negative. Change in entropy is negative. Therefore, this process is not spontaneous. It is a non-spontaneous. But if we consider iodine crystals placed open to the atmosphere, they are converted to iodine gas because entropy is positive. Even though entropy change is positive, even though that is the endothermic change. Here also, ice absorb heat and convert it to liquid water, but still that is spontaneous process because entropy increases, disorder increases, delta S is positive. Here delta S negative, so iodine gas cannot be converted to iodine solid, but iodine solid can be converted to iodine gas because at that time delta S will be positive. Similarly, if we consider the case of calcium carbonate broken down, converted to CaO and CO2 gas, this is solid, this is also solid, but this is gas. So in this process, what happens to entropy? Increasing or decreasing? Increasing. Solid is converted to gas. One molecule is converted to two molecules. Therefore, randomness increases, disorder increases, and entropy also increases. Entropy change is positive. So, it is observed that the processes in which entropy change is positive, even though they are endothermic, they are spontaneous. So what we can say on the basis of entropy? Here enthalpy we have studied. Now similarly write down about entropy. Entropy change. Whenever delta S positive means delta S is greater than 0. This process is known as a spontaneous process. Secondly, whenever delta S is negative, means delta S is less than 0. This is known as a non-spontaneous process. Non-spontaneous process. And third case, whenever delta S is equal to 0, this is the process at equilibrium. Thus, even though some reactions are endothermic, still they are spontaneous, can be explained on the basis of concept of entropy. So, two concepts for spontaneous process we have studied, that is enthalpy change. Criteria of exothermicity is required for a spontaneous process, but some of the processes are spontaneous even though they are endothermic. Why they are spontaneous even though endothermic can be explained on the basis of entropy, which is the measure of disorder or measure of randomness present in the system. And it is studied like this: if delta S is positive, they are spontaneous, negative means non-spontaneous, and if equal to 0, the processes are at equilibrium. But this criteria is also not sufficient to explain some of the processes which are spontaneous, to which entropy change is also negative. There are some processes in which entropy change is negative. See, for example, I am telling here one example. See this reaction: hydrogen gas plus half O2 gas giving H2O liquid. This is gas, and they are converted to liquid. So gas to liquid, what happened to entropy? Is it increasing or decreasing? Decreases. Because I have told you, measure of randomness, disorder is maximum in the gases and less in the liquid as compared with the gases. Therefore, entropy decreases. So, for this reaction, delta S is negative. So, this reaction should be non-spontaneous. But this is a spontaneous reaction. These reactants react together. Forming water is also a spontaneous reaction. Why this is spontaneous? Even though delta S is negative, is not explained over here on the basis of entropy change. So why that is negative can be explained with the help of Gibbs-Helmholtz free energy. That part we will study in the next lecture, that is lecture number 16. Here we must know the important points. I am revising the important points: enthalpy and entropy. The reactions which are exothermic in nature have delta H negative. The reactions which are endothermic in nature, delta H is positive. And the reactions which are at equilibrium will have delta H equal to 0. And it is observed that naturally occurring processes taking place with decrease of energy, means naturally occurring or spontaneous processes are exothermic processes. But there are some examples. I have told you the conversion of ice to liquid is endothermic, and that must be non-spontaneous. That should be non-naturally occurring process. But that is also naturally occurring process. Why that is naturally occurring process cannot be explained with the help of exothermicity. Therefore, concept of exothermicity is not sufficient criteria. And hence, the criteria of entropy is discussed. Here, that entropy is a measure of disorder present in the system. Solid converted to liquid, liquid to gas, disorder goes on increasing, entropy also goes on increasing, and therefore the processes are spontaneous. So for spontaneous process, change in entropy is positive, change in enthalpy negative, but entropy positive. For a spontaneous process, change in entropy is positive, therefore solid ice is converted to liquid water in the nature, naturally it absorbs heat and converted to liquid state, that is spontaneous. But still that criteria is also not sufficient, because see this example, gases converted to liquid, entropy decreases, delta S is negative, so this should be non-spontaneous, but it is also a spontaneous. This is also a spontaneous, even though it is negative, but it is spontaneous like this. Why spontaneous cannot be explained over here. So the concept of Gibbs energy is developed, that is the important criteria